Hello, my name is Adeline Deinhardt.
And I'm Lindsay Thornton.
And we are both education specialists here at NASA Langley Research Center. Today, we'll be demonstrating both the complex and simple versions of the 3-2-1 takeoff activity.
In this activity, students will explore the four forces of flight and Newton's third law of motion when they construct small soda straw X-planes and fly them by producing their own thrust by blowing through a straw.
For the simple version, students will have planes to cut out and build, while the complex version tasks students to design and build their own X-plane.
Prior to starting either version, you should review with students the four forces of flight, Newton's third law of motion, and how these principles affect aircraft.
Now, we'll demonstrate the simple version of 3-2-1 takeoff. For the simple version, you will need the X-59 paper airplane template printed out in either the color version or the black and white version, scissors, tape, and drinking straws. First, you'll cut out each template and give each student one. When cut out, the template should have two images of the X-59 mirrored across the middle solid line, as you can see here. Then, students will fold the template along this middle line so that the X-59 is on the outside of the paper. You will then take your tape and tape the entire length of the template closed. It is important that you ensure you have a solid seal here and that no air will be able to escape when you fly your airplane later on. As you can see, we taped both the top and the side, all the way through. Next, you will fold the paper airplane 4 times at the fold marks at the top of the template on each line. Again, you're going to want to tape these folds tightly and make sure you have a tight seal. And at the end, you'll end up with a paper airplane that looks like this. You can now place the straw into the body of the airplane and make sure it's able to smoothly slide off the end, as we have here. You have now completed your airplane. When having students test, it can also be beneficial to have a target for students to aim and test the accuracy of their flight. This is a target that we use here. To test the airplanes, have students blow into their drinking straw to fly their airplanes. They're going to want to do this 3 times and measure the distance their plane flew each time. Remember, the target is a tool to practice precision of flight, but it is important to be far enough away that you'll be able to record the distances and any observations they have about the flights in their data table. After students have finished their flights, discuss how the 4 forces of flight acted on the planes and what, if any, adjustments they made to make their planes fly further between each test. For example, did they blow harder to create more thrust, or did they angle their straw and plane differently?
Next, we'll demonstrate the complex version of 3-2-1 takeoff. For the complex version, each student will need a printed X-plane template, scissors, tape, a sharpened pencil, and a drinking straw. For the first paper X-plane, students will carefully cut out the rectangle and the wing shape. Then, using a pencil as a guide, students will wrap the rectangle lengthwise around the pencil and tape it to form a tube, like so. Remember to tape the entire length of the tube to create a solid seal and make sure that it is still able to slide on and off of the pencil. Then tape the wing shape onto the top of your tube and ensure the tab lines up with the rear of the tube, like so. Next, using the sharpened end of your pencil, twist the top of your tube into a nose cone and securely tape it. You have now finished your first paper X-plane design. Prior to testing, have students measure the plane in centimeters from end to end and record in the data table. When having students test, it can be beneficial to have a target for students to aim and test the accuracy of their flight. Now to test, have students replace the pencil with a drinking straw and blow into the straw to fly their X-plane. Have students conduct 3 flights and record the distance for each flight in the data table. For the second design, students will pick one variable to change to try to increase the distance the plane will travel. Students may choose to change the length of the body of the plane or the shape of the wings. However, they can only choose one thing to change at a time. They'll then use the provided area on the template to design and cut out a new X-plane. Once students have designed and built the second design, they will again test 3 times and record the distance traveled for each flight. Finally, students will calculate the average distances for both designs and compare their results to determine if their adaptation was successful at increasing the distance traveled.
You can wrap up both versions of 321 Takeoff by discussing with students the included discussion questions and how NASA engineers must take into account the forces of flight and Newton's third law of motion when designing aircraft, including the X-59 Quiet Supersonic Technology aircraft, NASA's newest X-plane. Thank you for joining us as we demonstrated 321 Takeoff, and don't forget to watch our videos about how the X-59 will fly faster than the speed of sound without producing a loud sonic boom.